Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So as per the problem, determine the minimal distance from point -3, 3 to the curve given by y equals x minus 3 squared. So we have to find the minimum distance between this given point and the given curve. As you can see, the equation of the curve represents a parabola because it's a quadratic equation. So we should sketch this information just to get a sense of what's given and what we need to find. Now we don't have to graph it on a grid paper, but we can just draw a parabola. Let's assume this parabola represents this equation and there is this given point. So let's assume the point is somewhere here, -3, 3. Now we have to find the minimum distance between this point and the parabola. Now as per this diagram, the minimum distance will be represented by this red line joining the given point and the given curve. Now the first step is to find the coordinates of a general point that lies on this curve. So let's assume the x coordinate of that point on the curve is x. Now as per the equation, if the x coordinate is x, then the y coordinate of that point will be x minus 3 squared. So this is a very important concept you need to understand to solve this problem. Now we can find the distance between these 2 points, the point on the curve and the given point, using the distance formula. And the distance formula is x2 minus x1 squared plus y2 minus y1 squared under the square root. Now here we can use x2 and y2 as the point on the curve. So we get x minus -3 and then square plus and then x minus 3 square minus 3 in parentheses and then square, and now we put the square root. So this is the expression for the distance between these 2 points. Now we can simplify this expression. So we get x plus 3 in the first parentheses and then square and then plus. Now in the second parentheses, we can expand the square on x minus 3. So we can do it on the side. So x minus 3 square can be expanded as x minus 3 times x minus 3, which can be expanded further using the FOIL method. So we get x squared minus 3x minus 3x plus 9, which can be simplified to x squared minus 6x plus 9. So we can use the expression in this distance equation. So x squared minus 6x plus 9 and then minus 3 and then close the parentheses and square. Now we can combine like terms in the second parentheses and we can change the square root into a rational exponent because that will make it easy to find the derivative of this function. Square and then plus x squared minus 6x plus 6 and then square and then the outer exponent and exponent, outer parentheses and exponent half. So now we have to find the derivative of the function because we have to find the minimum distance. So we have to find the x values at the valleys in the graph of this distance function. So at the valleys, the slope of the tangent will be equal to 0. So we'll find the derivative of the function and set it equal to 0. Now for the derivative, we have to use the chain rule because there is an inner function and there is an outer function. The outer function is the exponential function with exponent half. So we start with the derivative of the outer function and we'll use the power rule. So we move the exponent to the front and then times x plus 3 squared plus x squared minus 6x plus 6 and then square and then exponent half minus 1 times the derivative of the inner function. So the inner function is made up of two terms. The first term is x plus 3 squared. So we'll have to use the chain rule for that. So we'll start with the derivative of the outer function. So 2 times x plus 3 times 2 minus 1 times the derivative of inner function, which will be 1 plus 0 and then plus. Now again we'll have to use the chain rule for this second term. So we'll start with the derivative of the outer term. So outer function, so 2 times x squared minus 6x plus 6 and then exponent 2 minus 1 times the derivative of the inner function, which is x squared minus 6x plus 6. So the derivative will be 2x minus 6. So this is the derivative of the inner function. Now we can simplify this expression. So prime of t equals, now in the first part the exponent will become negative because half minus 1 is negative half. So we'll move that term to the denominator. In the denominator we get 2 and then x plus 3 squared plus x squared minus 6x plus 6 squared and then exponent positive half. Now we can simplify the numerator. So 1 plus 0 is 1 and 2 times 1 will be 2. So in the first part, in the second parentheses, we get 2 times x plus 3. Now the exponent is 1, but we don't write that. And in the second part, we get plus 2 times x squared minus 6x plus 6 times 2x minus 6. Now we can set the derivative equal to 0, and when we do that and when we cross multiply the denominator, so the denominator will go away. So we are just left with, so 2 times x plus 3 and then plus. Now we can distribute the terms in the parentheses. So we'll use the FOIL method and then negative 6 and this and then this and then 6 times 2x and then 6 times negative 6. So we get plus 2 and then 2 minus 6x squared minus 12x squared minus plus 36x and then 6 times 2x is 12x and then minus 36. Now we can get rid of the 2's in front of the parentheses. So if we divide each term by 2, the 2's will get cancelled out. So on the left side we'll just have a 0. So we can rewrite this as, so 0 equals x plus 3 and then In the second part, so we can combine the like terms. So we get 2x cubed and then minus 18x squared and then plus 48x minus 36. And now we can combine the like terms again. So 2x cubed minus 18x squared plus 49x minus 33. So this is the cubic equation we have to solve now to find the value of x at which the distance between the points will be minimum. Now here we'll have to use the rational roots theorem to solve this equation. So here the first x value we can try is x equals 1. So if we sub in x as 1, so we get 2 times 1 cubed minus 8 times 1 squared plus 49 times 1 minus 33. So f will be equal to 2 minus 18 plus 49 minus 33. And if we combine these values, we get equal to 0. Now there is no other solution to this cubic equation. So that means that the distance is minimum at x equals 1. Now we have to find the minimum distance. So for that we'll sub in x as 1 in this distance equation. So this is the equation we'll use. So we get distance equals the square root of 1 plus 3 squared plus then 1 squared minus 6 times 1 plus 9 minus 3 which is 6 and then square. Now we can simplify this expression. So 1 plus 3 is 4 and 4 square is 16. So we get square root of 16 plus and then 1 square is 1 minus 6 plus 6. So it will just be 1 squared. So therefore the minimum distance is equal to square root of 17. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So the first thing is to understand that we have to find the distance between a point on the curve and the given point. So we can use the equation of the curve to find a general point on the curve, and then we use the distance formula to find the distance between the points, and then we find the derivative and set the derivative equal to 0 to find the value of x. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.